In section 5.4, we're going to learn about complex fractions. The nice thing about this is we don't have a whole lot to learn in this section. Yes, these problems look very different, but as long as you learned how to find the least common denominator in section 5.3, that's all you really need to know what to do. Find the least common denominator, and then we're going to multiply every single term by that LCD, and all the fractions are going to disappear. So let me demonstrate it for you. So look at this denominator, and this one. And by the way, the definition of a complex fraction is a fraction that contains a fraction. So anytime you have a fraction that contains a fraction, or a fraction that contains a decimal, that means it can be simplified. So I'm going to look for the LCD. So my training says write everything you see with the highest exponent you see. I see a 2, I see an x, and I see a 5. 2x, 5. So my LCD is going to be 10x. And the book is, the book Alex is going to try and teach you two different methods. You don't need to know two different methods. This method works for every single problem, and it's by far the easier of the two. So I'm not even going to teach you the second method because you don't need it. So now we're going to take that LCD and we're going to put it in the numerator of every fraction. Think back to when we were solving equations the very first week of school. Remember how we learned how to multiply every single term by the LCD to get rid of fractions? Doing the same thing right now. And so multiply this one by 10x. And I'm just extending the numerator so that you can see that there's canceling. Okay, so after you multiply every term by the LCD, then you cancel what's common. So 2 goes into 2 once, 2 goes into 10 5 times. So do you see now that you have 5 times x times 1, which is 5x, plus, here the x's cancel, x divided by x is 1, so I have plus 30 over, here 5 goes into 5 once, 5 goes into 10 twice, 2 times 2 is 4x. That's how easy simplifying a complex fraction is. So stuff you learned the very first week of school. So multiply every term by the LCD, which means write everything you see without repeating with the highest exponent. And then do your canceling. 2 goes into 10 5 times, 5x times 1, 5x. X divided by x is 1, 3 times 10 is 30. 5 goes into 5 once, 5 goes into 10 twice, so we have 4x. And then the last step is the same thing you learned in 5.1. Simplify. Factor anything that can be factored, and if there are any like terms, cancel. So here I see a GCF. Remember, two terms, GCF first. So I take the 5 out, divide this by 5, divide this by 5, and I get x plus 6 over 4x. That's a single term, so that can't simplify. So I look and see, is there anything in common? No. So that's my answer. And that's what we're going to do on every single problem in this section. Multiply by the LCD, get rid of the fractions, simplify your result. So you can cross out these directions. This is the first method they teach you in Alex, and we're not going to do this method. So this is what we're going to do, exactly what I just demonstrated for you. Multiply every term by the LCD to remove fractions. Simplify, factor the result. So let's go ahead and write this first problem nice and big. And I will tell you most of the mistakes on this is students don't read their work correctly because there's so much crossing out they can't read what's left, or they skip something that's left. So I always recommend to students write it big before you start doing any canceling. Write the problem nice and big, and then it's a lot easier to see what you have after canceling. Oops, I wrote that backwards. 3 over x. Wow, how did I do that? So 3 over x minus 2 over y. Okay, so now we're ready to find the LCD. So remember, we write everything we see with the highest exponent we see. I see an x, I see a y, I don't repeat, here's another x, I don't repeat, another y. So my LCD is xy. So beside the numerator of every fraction and beside every whole number, if there's any whole numbers present, we write xy. And remember, this step is to remove fractions, so remember to cancel. So x over x is 1. So what does that leave me? That leaves me with 2y plus y over y is 1. That leaves me with 3x. X over x is 1. That leaves me with 3y. And y over y is 1. That leaves me with minus 2x. So do you see how I did one step of work and I got to the answer? Look how many steps this method required. Why would I teach you that if you can do it in one step and get the exact same answer they got? Doesn't really make sense to learn it, does it? Not if you're not going to need it for something else. So this method works for every single one. So when they say use method 1, use method 2, you can use this method on all of them. I would maybe go the next step and write this in the correct order. 3x plus 2y negative 2x plus 3y. And you can see nothing cancels, nothing factors, there's no GCF, there's no like terms. So we can't do any canceling because of the addition sign. We can't do any factoring because there's no GCF and no exponents. So that's how easy the problem is, folks. Not bad, huh? Okay, shall we practice? Let's do one more together and then you can work on 2. How about that? So step 1 is write it nice and big. 9 plus 3 over v. Oops, move the paper up, Norris. Over v over 4 plus 1 over 12. So if you were adding two fractions that had a denominator of 12 and 4, what would your common denominator be? It would be 12, right? So when you have two numbers, if one of the numbers goes into the other number, that's your common denominator. So if I was adding two fractions that had denominators 4 and 12, my common denominator would be 12. Up here, I have a 1 and I have a v, but remember for LCD, you have to write everything you see. So this, if you factored it as, let's go over here, if you factored 4 as 2 and 2, and 12 as 2, 2, and 3, so if you write everything you'd see, you'd write a 2, and a 3, which gives you 12. Because you don't add and write 4 2s. You can't duplicate. So 2 2s and a 3, which is 12. And we have to include the v, otherwise you won't get rid of the fraction on that problem. So every single denominator has to come into play. 4 goes into 12, so 12's the LCD down here, and then we have a v. And I've seen some students incorrectly do this on the test. They multiply these by v and these by 12. You can never do that. Whatever you do to the top of a fraction, you have to do the same thing to the bottom. So don't multiply the top by v and the bottom by 12. It has to be one LCD for the entire problem. So multiply by 12v, multiply by 12v, multiply by 12v, multiply by 12v. And remember what I said, put it in the numerator so you know there's going to be canceling on the next step. Because your goal is after this step, there should only be one fraction bar. There should not be 1, 2, 3, 4 fraction bars. There should be one fraction bar. So we have 12 times 9, which is 108, I believe. Yep. So we have 108v plus, and here v divided by v is 1. So that would be plus 36 over 4 goes into 4 once, 4 goes into 12 3 times, so that would be 3v times v. Wouldn't that be 3v squared? Because in multiplication we have to add exponents. So 12 divided by 4 is 3v squared. Plus 12 divided by 12 is 1, so we get plus 1v. Excuse me, which is just v. So remember, don't stop here. Don't do all that work you just did and miss the problem because you forgot to simplify. We always have to simplify. Look for GCFs, look for squares, look for cubes. So up here, I believe 36 times 3 is 108. I'm going to check for sure. 36 times 3. Yep, it is. So I have a GCF of 36 here. So I can pull the 36 out, divide each of these by 36, and then write what's left. We just said 108, 36 times 3 is 108, so 108 divided by 36 is 3, and then we still have that v, plus 36 divided by 36 is 1, over, remember, two terms. The first thing you're always supposed to look for is GCF. What's common? V. So now I can take a v out of each term and write what's left in parentheses, and then I can look for something common. So 2 minus 1 is v to the first, so I have 3v to the first, plus anything divided by itself is 1. And look at that. Ding, 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 ding. Common factor. So my simplified answer is simply 36 over v. So even though these problems look different than anything you've ever seen in your life, probably, maybe, everything we've done you already knew how to do. In the first day of class, we learned how to multiply every fraction, every whole number by the LCD to get rid of fractions when you're solving an equation. We did it again in the last section, 5.3, found common denominators. We just didn't get rid of the fractions. And we spent all of chapter 4 learning how to factor. So nothing we did in this problem is new. Yes, they look very different, but we're using old skills to work the problems. Okay, so on page 2, there's 2 problems I would like you to do at the top. So before you start the next video, please try number 2 and 3 at the top of page 2. and then turn on your video and we can compare answers.